Hello chemistry students, this is Nico, and in this video we're going to take a very brief look at the pH scale. Alright, and it's not a discussion of acids and bases without talking about the pH scale, because we're going to, when we deal with acids and bases, primarily talk about their behavior in solution as affecting the pH of a solution. Now, the pH scale is used to determine whether or not a substance is acidic or basic. All right, so what exactly is the pH scale? Well, it's a log scale, all right, of the hydronium ion concentration. All right, also commonly be referred to as the hydrogen ion concentration, but just take note that they're just simplifying just there. Now, it ranges from 0 to 14, and it's built around the ionization of water, which is a concept we'll explore in a later video. All right, so how this scale works? Well, how this scale works is in recognizing that when we refer to a solution that has had a solution of water that has had an acid added to it, we're talking about water and its relationship with hydrogen ions and hydroxide ions in the following equilibrium situation. Now, when we have a pH of 7, that's attributed to what we call a neutral substance, i.e. pure water. But when we have a pH below 7, all right, that means that we have extra hydrogen ions in solution. All right, and again, we have an excess of hydrogen ions or hydronium ions in solution. Likewise, when a solution is greater than 7, all right, that indicates that we have an excess of hydroxide ions. Okay, so looking at this, when we take a look at our pH scale, okay, all right, in the middle here at pH 7, it's neutral, so that's pure water. All right, if we have above 7, we have a basic solution, or an alkaline solution is another word for the same term. All right, and that means we have an excess of hydroxide ions in the solution. All right, likewise, if we have below 7 heading down to 0, we have an acidic solution. We have an excess of hydrogen ions in solution, so we have extra hydrogen ions in solution. Now, the other thing to note is that the pH scale is a log scale, and it's to a log base 10. All right, and so what that means is if we go from a neutral pH of pH 7 to pH 6, our solution has become 10 times more acidic. We go to pH 5, from the original 7, it's become 100 times more acidic. So each unit is a factor of 10. Okay, it's just something to be mindful of. Now, in looking at this, it's a nice way to finish off of this is just to talk about some common substances that we find in the world around us, everyday substances, and their pH. Now, you're going to have to, in your study notes, assemble a table similar to this. It's going to have to be much more extensive, and just talk about the different substances we encounter throughout the course, and whether or not they're acidic, neutral, or basic. All right, now specifically, if we take a look at our acidic examples just here, inside us, in our stomach acid is actually hydrochloric acid, and that has a pH of 1 in our stomach. All right, that might surprise you a little bit, but that's how we actually break down our food, through acid digestion. Okay, Coca-Cola, this is why people say Coca-Cola will damage your teeth, has a very low pH, in addition to having a large quantity of sugar, potentially, if it's full sugar Coca-Cola. All right, and so that can cause acid damage to your teeth. Coffee has a relatively low pH as well, a pH of 5. All right, likewise, neutral substances, we've got pure water, and many of the fluids in our bodies are actually relatively close to pH 7. Human saliva is about pH 7. Human blood's about 7.4. All right, and conversely, many of the cosmetic products that we use on our skin, or moisturizers and so forth, for them to work effectively, they try and maintain the correct pH on our skin, for example, and they will try and maintain that pH, and so they'll be around 7 as well. And likewise, we have, when we talk about basic substances, which actually encompass many of our cleaning products, all right, we have soap, which is pH 9, bleach, which is a stronger cleaning product, it's pH 12, and drain cleaner, which is often sodium hydroxide itself, is pH 13. All right, so just to wrap up, in review, in this video, we have talked about the pH scale very, very briefly, just introducing it and nutting out where and how it works, all right, and how to actually think about the pH scale when you're using it, notably it being a log scale to a base of 10, which means that as we move up or down a pH unit, it changes by a factor of 10. Okay, thank you for watching. If you have any questions, feel free to ask in the comments below or in class.